Welcome back, I'm That Chemist, and today we're going to be deciding which molecules are the most cringe. So let's start with an interesting one like sulflower. So sulflower actually only has sulfur and carbon in it. It doesn't have a single hydrogen atom in it. It doesn't have any interesting applications other than looking cool, but it's pretty interesting to see something with that many rings and not a single hydrogen. So I think we can put that one into at least B tier. Now another interesting one is triangulene. As you can see, it has 6 rings, and it also has 2 radicals. It isn't super stable, although it can be isolated and characterized at low temperatures. I believe researchers were able to look at this for a total period of 4 days when kept at ultra low temperatures. So this one's definitely pretty cursed. I think we could put this one right into A tier. Now this next one's pretty interesting, azisivoflurane. This one has an interesting motif called a diazirine, and so diazirines are used as photoaffinity labels. This is a type of motif that biologists often use to label proteins, for instance. So if they want to make like a drug interact with a receptor, what they'll do is they'll put this thing on here, which is a type of photoaffinity label, and when it's irradiated with the appropriate wavelength of light, which could be UV light, although it could also be formed using something called Dexter energy transfer, as has been studied by the Macmillan group. These things are able to label the target receptor. So if you're not sure which receptor a drug is interacting with in the body, one thing you can do is make a photoaffinity labeled analog of it, and that can help elucidate the mechanism of activity of that drug. So diazirines in general are fairly cursed looking. You see 2 nitrogens in a very unhappy arrangement. I think maybe diazirines in general can go into A tier, but specifically with azisivoflurane, I think it's probably a little bit worse. This is actually an analog of an anesthetic called sevoflurane. Sevoflurane on its own has a lot of fluorines, and this is no exception. The only difference here is they've extended it by an additional carbon just to put in that diazirine group. So definitely a fairly cursed looking molecule. If it's that perfluoro, it's probably cursed. S tier. Here's an interesting one. This one has a terminal iodide sticking off of an alkyne, an alkynyl iodide. So you look at this and you assume the only application of this, if you've never seen it before, it must be just something a synthetic chemist used. But it's actually a fungicide used in lots of consumer products. It's also used in preservatives more broadly speaking, and even though this one has a fairly good safety profile, this one still gives me the EBGBs. So I think this one at least goes into B tier. Seeing an alkynyl iodide definitely turns me off from wanting to have a product that contains that, because that's a fairly weird looking motif. You can let me know if you disagree down below. Now on bisoprolol, you can see that there's these 2 isobenzotriazole motifs, and this is kind of weird looking. Again, you might wonder, what the heck kind of application does that have? And it turns out that it's actually an ingredient in sunscreen. It's good at reflecting UV light, and it's also good at absorbing both UVA and UVB. So this one, in my opinion, is super duper cringe, and I think this one has to go right into S tier. Now another one that grabs my attention is bibrocathol. Bibrocathol is kind of interesting because there's only 1 hydrogen on it, and it's sticking off of the bismuth. It's also got 4 bromines on it, on this benzene ring. So this benzene ring looks kind of terrifying. Definitely makes me cringe seeing something that's that substituted, and it turns out that this one's actually used to treat eye infections. Now I personally wouldn't want to have that anywhere near my eyes just looking at the structure, but the doctors say it's okay. I guess it's probably okay. This one's a little bit worse than the iodide. I think this one can probably go into A tier. Another really noteworthy one here is tempo, and so tempo is a stable radical. The reason organic chemists will typically use this one is to probe reaction mechanisms, as that radical can terminate another radical that you form in your reaction. So this is a stable radical on its own, although if you have a radical that you form in a reaction, this can react with it and trap it out, and then you can look for that adduct by like mass spectrometry or other methodology. So it can be useful for tuning out the mechanism of a reaction, and that can be really helpful for understanding how chemistry works. So tempo is pretty cool. It's a little bit cringe because it's got an unpaired electron. I think we could probably put this one into A tier, but it's not as cringe as some of the other ones here. So maybe let's put it into B tier, and maybe even C tier. We'll decide later on. So this one looks wild. You've probably never come across this one before, but this one's called Mirex, and it was actually used as an insecticide. Mirex has been used for the control of ants, and it was used to try and prevent the spread of the red fire ant, although it also killed native ants, and so that kind of didn't solve the problem, and then the invasive species was still invasive. So this one I think definitely has to go into S tier, because something with that many chlorines and no hydrogens at all is definitely extremely cringe. The next one we'll talk about is Benzvalene. So Benzvalene is kind of wild. You look at it and you don't really think it should exist. Doesn't look like it wants to exist. And Benzvalene is an isomer of benzene. It can be prepared from benzene, although many other isomers of benzenes are formed when you irradiate benzene with the correct wavelength of light. But it can also be prepared from cyclopenadiene with with methyl lithium as well as dichloromethane. So this one's kind of an interesting molecule. It's definitely a little bit cringe because look, two cyclopropanes bound together and it's just preventing this ring from being very happy. This is pretty cringe. I think Benzvalene probably belongs in A tier. Maybe we'll put it in B tier, but then we're gonna have to be a little bit harsher on tempo and put it into C tier. Now next we have one called Triquinacene. Triquinacene is an interesting molecule because triquinacene is a bowl. Methods of their synthesis are quite complex, and so very few analogs of these have been prepared. One thing people would like to do with these is do a cycloaddition where you add two of these together and you get dodecahedrane. Dodecahedrane's already been synthesized, but it's kind of like an organic chemist's wet dream to add these together. So this one's pretty cringe. You have those double bonds. They're kind of forced in a weird geometry. This whole thing's not super duper happy. It's not good geometry for a cyclopentane. We could probably put this one into B tier. Now, if you've never heard of anandamide before, this is one of the natural ligands for the endocannabinoid receptor. This is the receptor where THC would go, for instance. This one's definitely pretty weird looking. It's got several double bonds in a row, but they're not conjugated. They're like anti-conjugated. And so this kind of looks cool just because of the way it's drawn, but overall it's still pretty cringe because those double bonds, man, they would love to be conjugated. So for that reason, I think we're going to put it into A tier. This really interesting molecule here is one I just can't take my eyes off of. This is called Josamycin. Josamycin is interesting because it's a polyketide nucleoside and it has antifungal activity against several pathogenic fungi. So this one's pretty cool looking, except seeing all those cyclopropanes all in a row like that is super duper cringe. We also have an alpha beta gamma delta unsaturated amide. So this one I think is an easy S tier. If we run out of room, we'll move things over a bit. So superbenzene. It is super cool. Superbenzene actually occurs as a very rare natural mineral called carpathite. Superbenzene has also been used as a solvent probe. This one doesn't look too cringe in my opinion because it's extremely symmetrical. I think as it's super duper symmetrical and beautiful, I think this one has to go right into F tier. Now the next one that I think is extremely cringe is Nanopution. Nanopution is a molecule that was synthesized just to look like a person. There's actually a whole family of molecules called Nanoputions in general. Sometimes people call this one Nanokid. If it wasn't cringe enough for being a molecule that looks like a person, it also has this tert-butyl alkyne, which is kind of obscure and it's not a motif you see very often. So I think this one's easily the most cringe here, and I think this has to be like sticking outside of S tier because wow, it is super duper cringe. When you publish a paper on slang like this, it just makes people shake their head and they either love it or hate it. And for Nanokid, I am definitely a hater. Truxillic acid, this one's kind of cool because it's got a cyclobutane in it, and I haven't drawn any stereochemistry on any of the carboxyl groups or the benzene rings, and that's because there's several different isomers of these that exist. This is actually a naturally occurring compound that you'll find in certain foods such as cocoa. So truxillic acid, it's a naturally occurring compound. When it's heated up, it converts back into cinnamic acid. So this one's kind of cool. It doesn't look too cringe compared to the other ones. Although since it is a mixture of compounds, I think that's a little bit cringe, and so we can put it into E tier. This one's known as tetramethylene disulfotetramine, and this is often abbreviated to TETS. This is used as super rat poison. It's banned and no longer used in most places in the world, although apparently it still gets some use in China, even though it's banned. It's super duper effective, and it's also been used to poison people, which is terrible. So this one's pretty cursed looking. It's kind of hard to get the geometry across here. It's definitely weird to see two nitrogens bridged by an SO2 group. It's not super uncommon, but it's uncommon enough that it makes you shake your head a bit. So I think this one can go into C tier. Hexabenzocoronene. Hexabenzocoronene is one of the interesting ones here. It's extremely symmetrical. It's also been studied by atomic force microscopy, which is a technique you might not have heard of. It's commonly abbreviated to AFM. And it's the first example of a molecule with differences in bond order and bond lengths that they were able to measure in direct space. So that's kind of cool. This one's super symmetrical. It can go right into F tier because this is not cringe at all. It is super duper based. GenX. GenX is extremely cringe. You might be wondering, why is GenX cringe? What is GenX? GenX is a replacement for perfluorooctyl sulfonic acid, which is a PFAS, a perfluoroalkyl substance. All perfluoroalkyl substances are automatically super cringe. This one's been touted as a safer alternative replacement for perfluorooctyl and perfluorobutyl sulfonic acids, or other derivatives of C4 to C8 perfluorocompounds, but this one's just as bad, it seems. This one's been found in rainwater. It's been found everywhere. It's been used as a non-stick coating in commercial applications, which is the main thing that you'd use perfluoroalkyl substances for. This one's also used in things such as cosmetics, which is a little bit terrifying because they do bioaccumulate and they're not that good for you. Eventually, I'll make a video covering PFAS because it's an important topic that people need to know more about, especially if you're a consumer using non-stick compounds. One of the most concerning things about PFAS compounds is their use in waterproof cosmetics, because they just get absorbed right into the body. If you have it in lipstick, for instance, guess what that's going to do? You're going to get it in your mouth. And if you use it as mascara or eyeliner, guess what? It can get in your tear ducts. So that's not great. GenX super duper cursed. This one can go right into S tier. Now let's try and choose another interesting one. Oh wait, we have Grimace here. Grimace is awesome. Grimace is so great. Grimace is the least cringe thing on here. He's going to go right into F tier because he's so based. Show some love for Grimace down in the comments. But do you know what's not based? Tetradioxin. Dioxins are a persistent organic pollutant that are a byproduct of several industrial processes that contaminate groundwater and can be found almost everywhere. Super duper cringe. Absolutely terrible. This can go right into A tier. It has a little bit of symmetry, which makes it look a little bit less cringe, but it's still a cringe molecule. So this compound's reported to be a natural product, but as you can see, that has a lot of nitrogen content to it. It also has 5 nitrogens in a row, which we would call 5 contiguous nitrogens, and that's definitely something you don't want to see in most molecules. So that's a little bit cringe, but it also looks pretty based, because I think, down in our heart, we want to make that nitrogen-rich molecule as nitrogen-rich as possible. We want to pack that sucker full of nitrogen. We want to restore nitrogen order to the molecule. So this one can go in B tier. Cyclooctatetra blah 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 blah. So the next one here is cyclooctadecanoenene. Cyclooctadecanoenene's interesting because it's the first annulene to be aromatic after benzene. This is technically an aromatic ring, and that might upset some of you because it doesn't have a hexagon. And as we know, hexagons are bestagons. So this one is not a hexagon, so it is not a bestagon. So this one has to go into C tier. This one here looks a little bit like the fish from Subnautica, dodecaphenyltetracene. This compound is the largest perphenyllecene that has ever been prepared, and this doesn't really represent its actual geometry. So this middle group of 4 rings is actually twisted, and the whole molecule has a big twist to it. So that one's pretty cool. This one looks a little bit trypophobic to me, and I think that's definitely cringe. This one can go into C tier. So we have a few left. We have this interesting Mobius carbon nanobelt. This one's interesting because carbon nanobelts haven't been previously synthesized due to their high intrinsic strain. So some molecules in the shape of belts have been made before, and there's even been cases of molecules with Mobius topology, although they've contained other elements such as sulfur. So this one looks a little bit cringe because you want to see like a nice continuous ring, but it's also got some Mobius topology to it. And so for that reason, I think we could put it into C tier. So we have a couple really interesting ones here, such as Calicomycin. And despite what its name sounds like, it doesn't have anything to do with cowlicks. It actually has an enediene and this interesting trisulfide motif. So this is an anti-tumor agent, and it actually binds to the minor groove of DNA, and then it undergoes a reaction analogous to the Bergman cyclization, where we get 2 radicals that form, and this is able to abstract a hydrogen atom from RNA. After the hydrogen atom has been abstracted from RNA, this then causes strand cleavage, which can be effective at preventing tumors. So this one looks extremely cringe. Just look at this molecule. We don't even have room in S tier anymore for this, so we're going to have to put it beside S tier because it's super duper cringe. Look at that trisulfide motif. I would hate to have to synthesize something like this. It's just got so much going on that would be absolutely terrible to work with. Easy S tier. Another one that gives me similar vibes is kedarcitin. Kedarcitin is interesting because it's also an anti-tumor compound that's an antibiotic that was first isolated from an actinomycete. Similar to calicomycin, it also has this enediene, which is able to give it some anti-tumor properties. So this one's also extremely cringe. You can see that there's a ton going on. It's a little bit less cringe than calicomycin, so I think we should probably put it into B tier. Now we have 3 interesting ones left. We have carbon hexoxide, carbon pentoxide, and finally, falcarinol. Falcarinol is actually a natural pesticide, and it can be found in carrots. It's got this diene motif, which is a sketchy motif to be sure. If you were working with these synthetically, they are often quite sensitive, and you have to be a little bit careful when you're working with them. And it also has this out-of-conjugation double bond, which definitely would make me cringe. So for this reason, I think we could put this one into D tier. It's not super duper cringe like some of the other ones here, but it's definitely up there. Now, carbon hexoxide and carbon pentoxide. These are super duper cringe molecules. We're going to put both of them right into S tier, because they are both extremely cursed looking. You don't ever want to see carbon with more than 2 oxygens, but here we go. We have just absolutely pumped those carbons full of oxygen. It's known that these exist in the outer solar system in atmospheric chemistry, and they've also been prepared in a laboratory setting under extremely controlled conditions. Which gases are the most toxic? Ethylene oxide looks like a women's bathroom sign, and those can be pretty toxic. They can indeed. And never forget, Grimace wants you to have a great day, because Grimace, he's just so awesome.